Minasan, konnichiwa, Zamurai Engineer test. So in this lecture, we will continue giving example, problem solving example on topics that we already discussed. So let us try to confirm the sound check if we have clear sound. Can we confirm? Okay, thank you for confirming. Shout out kay Malsada. Okay. Okay, let's proceed. So we can just use what we have. Very poor Wi-Fi connection, very poor quality of gadgets. Anyway, let us do it as good as we can. Okay. So thank you for attending this class. We're already more than an hour late, but let us cover all the things that we have planned. So as you can see, we have our on your screen our main reference textbook. So let us go to our topic. So practice problem. So we are currently right here. So we will add some more problems today, but we will repeat the last week's discussion. Okay, so that I would like to give you more time to think about it, to clarify some things in your head. If you have questions, we are willing to talk it over this online live stream lecture. Okay, so I will share I hope it is clear. I will share a piece of paper. I hope you can see it right here. Can you see it clearly? Okay. Before we proceed, is the writing on the paper clear enough so that we can proceed? Or I need to maybe make it bigger, a little bit bigger? Any comment about this? Is it clear? You can read it? So if we can read it, I will just proceed. This is actually the reason why this setting up cost me more than 1 hour. This is a new application, mind you. New application, and I'm not yet very aware of this. So I connected my camera through EYPEI. Okay. So anyway, let us not waste another moment. So problem 001, we are given B and D dimension. We are also given the quantity and size of reinforcement. We are also given the important properties of the material, okay, in terms of its strength, okay, strength capacity of concrete, strength capacity of steel. So we are given. So we are being asked to compute Mn values. So what we are going to do is find Mn. Okay, so solution. Again. Okay. If this is the only given and there are no other ways to imagine the figure, because it is much better if the cross-sectional area and the inclusion of reinforcement clearly indicated on the cross-sectional area. That is our ideal situation. However, if the situation is given the dimension of the cross-sectional area, so let us imagine it. Let us therefore imagine we have this type of cross-sectional area wherein we can find out B is 300. Okay, so this means we have 300 and 600. So here we have 600. So 300 by 600. Okay. But as you can see, 600 is D. It is not H. So take note of the difference. If this is the figure, this is supposed to be BH. Okay, take note. Very important thing. Very important thing. So remember, if you draw it this way, this is supposed to be BH. But the given is BD. What do you mean by the BD? BD is only up to this point, from the top extreme fiber to the center of reinforcement. Take note, I am using the word center of reinforcement. So, for example, we have how many reinforcement? 3. There are 3 reinforcement. I can draw it this way, such that the center of reinforcement up to the extreme compressive fiber is 600. Now, this is the correct way we have to draw this given. Take note. Immediately, if you cannot draw this correctly, you will have the wrong answer. Okay, this is how you do it. Okay, after making this drawing, therefore we have what? We have our crack model. Okay, crack model. So, meaning to say, this is our dimension. Okay, for A. Okay? And this is our dimension D minus A, because we have D minus A, so we have this from the neutral axis. Okay, so actually this is not the neutral axis, this is the model, the estimate that we want to use in order to model the actual. Okay, so what is our model? So I will write down our model. This is how we model it as an estimate. Okay, so this is how we model it. So we have the resistance being contributed by the reinforcement, and we call that as T, representing tension, okay, tension force. And the model itself is actually like this. Okay, so we are modeling the stress as what? As uniform stress. Okay, we are modeling as uniform stress. In reality, this is not uniform. This is not rectangular. In reality, this is somewhat like a curve. This is like a what? A that looks like something parabola. Okay? Okay? This is not exactly parabola. This is not exactly parabola, but it is looking like, okay, a parabola. Okay? And the estimate looks like this. Okay? We use rectangle because it is the simplest model that we could represent the actual. Okay? So, and according to the code, the magnitude of this uniform stress is represented by 0.85 FC prime. Okay, that is the magnitude of this uniform stress. Okay, so meaning to say that is magnitude. This is A and this is B. So therefore, we have the complete dimension. And because this is uniform load, we can represent this as a single compressive force. Okay? Okay. So that we can initiate a mathematical computation wherein we identify that C and T are equal, okay, in order to give us the static equilibrium. Okay, static equilibrium, they are equal in opposite direction, and equal opposite direction forces, we call it couple in mechanics. Okay, so since this is a couple, we can multiply this by the moment arm, and the moment arm is from the center of this, which is the middle is A over 2. Therefore, the moment arm is A over 2. And therefore, this is D minus A over 2. Okay? From the distance between the couple. Okay? So, therefore, this area, the total force C times is equal to the total force T, we can equate to each other. So, for example, T, this is just the total area of the steel and multiply by Y. Okay? So, for the total area, that is 3. And if we can look at the actual, so number 36. Number 36, this is actually, so number 36, okay, number 36 is actually diameter 35.8. Okay. So we have that. We have the rebar size table. So I made up my own rebar size table, so I can again show it to you. I have to open that rebar bar sizes. Rebar size table. To find out that really number 36 is a rebar with diameter 35.8. And what about the area? The area of one piece of this area of one piece is actually, we need to look it up at the table or compute so that we can find out the total area of steel. So right now my gadget is not able to open. Okay, that's how low quality is my apps and gadgets. Take a look at what's happening. Just opening a document will cost us so much minutes. Just opening. So too much waste of time. Just take a look. Just opening an Excel. Just opening an Excel. It cost us too much. So I will show you the bar sizes here. So we have bar sizes. So 36. Look at this. So we have 36. Okay. So 35.8 diameter, and the area is actually 1006. Okay, the area is 1006. So there are 3 of them, therefore 3018. Okay, so this is coming out from the table. Anyway, we can compute it. Okay, so don't worry about this. You can compute this, and therefore the tensile force. So again, tensile force is just equal to that value 3018 multiplied by Fy, which is 350. multiply by 350. Okay, so that is our if you multiply it, so 350 multiplied by 3018. Okay, I will show you our calculator. So this is our calculator. So 350 by 3000. So if you press this equal sign, so that is our value, 1,056,300. So that is 1,056,300. Okay. And then what about C? So C is therefore 0.85 FC prime times AB. So we do not know what is A, therefore we can find out the value of A. So let us form the equation. 0.85 FC prime is 35, B is 300, and multiply by A. So we can therefore divide this one by 0.85 divide by 35 and divide by 300. Divide by 300. Okay, so that we can find out what is the value of A. So therefore, if we compute that, the value of A is 118.4. Okay. So using three significant figures, our answer would be 118 mm. Okay. 118 mm. So any question? So after this one, let us go to solve for the nominal moment, which is T times this one, or C times this one, because C and T are equal to each other, so we can just multiply any one of those values, multiply by D minus A over 2, which is now equal to T. We already found out the answer. Just write it down, multiply by D, which is 600, minus A, which is 118, divide 2, and that's it. Okay? Therefore, if we use again our calculator, so that is 1,056,300, that is our T, multiply by 600 minus 118 divide 2. Okay, so this is our answer. This is 571 million, but let us divide by 1 million to change mm to meters and to change newton to kilonewton. So therefore, if we use three significant figures, our answer is supposed to be 571 kilo Newton meter. Okay? So that is our final answer. Okay? So this is final answer. Any question? Do we have any question? Okay, there is no question yet. I would like to move on to the next problem. So problem number 2. Let us proceed to the next one. P002. So let us again write down the given. From your screen, you have what? You have 350. 350. D is how much? 530. 530. Again, this is, I am doing this repeatedly so that we can be familiarized and memorize the procedure. Okay, the step by step. Okay, so number of bars. Okay, number of bars. 25. So number 25, how many? 3 of them. So 25 bars. Okay. Do we have FC prime? So FC prime. Take note again. These values are usually used values. This is not hypothetical. You can encounter this in actual. So FC prime 35, FC prime 24. These are usual values. Okay. FY 350, FY 420, those are usual values. Okay, take note again, since we are having a professional course, we are using the values on those examples wherein they can be encountered in the actual practice. Okay? So again, find MN. So what is MN again? So solution. So we have again to be able to imagine. We must be able to imagine what is going on. That's why we need to sketch at least. Okay? We need to sketch. So we have 3 reinforcement rebars. So again, we have the dimension. What is this? D, which is equal to 530. B is 350. Okay, we have something like this. And what else? What is our model? So our model is this one, crack model. This is our crack model. So we have here the crack model. So what do we have here? Crack model. We do not know what is A. So this is D minus A. This will contribute the total tension force. Okay. What about this one? This will contribute a uniform compressive force that is equal to 0.85 FC prime. Okay, and this is A. So at the middle, at the center of this, we have this one is what? A over 2, because that is 1/2 of A. Therefore, this is D minus A over 2. And this actually, the total of this is actually C. Okay? So the total is actually 0.85 FC prime AB. So we can obviously compute that. So 0.85 times, so we can use again our calculator. So let us use calculator to compute 0.85 times FC prime is given to be 24. Okay, times B, which is 350. We do not know A, so we can leave that as it is. So the answer would be 7,140 times the value of A. Okay. Now for T, let us take note or compute the area. Okay. So number 25 bars has diameter how much? So let us again get back to our table. So 25, this is, so the actual diameter is 25.4. So 25.4. You can compute it, then you can compute the area 1, meaning area, cross-sectional area of 1 bar. This one reinforcement, cross-sectional area. According to the code, that is 510. Here, this is the area, 510. So we have equal to 510. That is the area. Okay? And there are 3 of them. So therefore, the total area of steel reinforcement is times 3. So 3 times 5, that is 15. 3 times 10, that is 30. So this is the total area steel. So therefore, we can what? We can solve for the value of this tensile force. So this is what? ASFY, and that is 1530 times 420 times 420. Okay, so how much is this? Again, use our calculator. 1530 times 420, we have 642,000. 642,600. Okay, and equate C and T. Equate them. Therefore, C is equal to T. We have 7,140. A is equal to 642,600. Therefore, we can solve for A. So this is, we have to divide by 7,140. So the answer would be 90. Okay, exactly 90. Okay, so 90 mm. Okay, you have to check it on the figure, on your drawing, on your sketch. Is this possible? This must be less than 1/2 of D. Oh, okay. It is okay. It is possible. Less than or less than 1/2 of D. Okay, so it is possible. Okay. Okay, so it is about how much? It could be 1/4 to 1/3. It could be 1/4 to 1/3 of D. Okay, so this value is okay. Therefore, we can now proceed to solve the moment nominal, which is what? T times the moment arm, which is T minus A over 2. Therefore, we can write down what is D, that is 530 minus 90 over 2. Okay, and therefore we can have our final answer. So 642,600 multiplied by, I am showing you up to the calculator how to do it. Then later on you can practice a lot more and gain speed. You have to gain speed. So 90 over 2 is 45. Therefore, equal to how much? This is 311 million 661. So for three significant figures, divide by million, because we want to convert to meters. That is 1,000. Another 1,000 for converting to kilonewton. So three significant figures, 312. So 312 kilonewton meter. So this is our final answer. Okay. Any question? So we prepare for the next one while I am looking at your you can notice the shadow. I do not have another gadget. For example, I may be needing what? Lighting, focus lighting. Okay, because we have shadow here. We have shadow, and actually the shadow is what? The shadow is actually the camera. The shadow is the camera. This is the shadow of the camera, and the lines, the shadow lines here are the stick that supports the camera. That's how we have a very low quality setup. Okay? Zero cost, but it is very costly with respect to time. Okay? So let us move on to the next problem. Problem number 3. So for problem number 3, let us move back to our problem number 3 is better because we have already a given sketch. We have a given sketch, so it's better. Okay, so problem number 3, we have a given sketch, and still we are going to find Mn from this figure. Okay, find Mn given the figure. So the given figure is this one. So we have again a rectangular, but now instead of 3 we have 6 bars. So given is what? 6 bars of number, what is the number? 25? This is 25. 25. 6 bars of number 25. And we have B 350. And we have this dimension from this point to this point to this point to this point. So we have the following given: 460, this is 460, then 70, another 70. Okay, so therefore the value of H is 600. Okay, so but the center, okay, the center of this 35, so therefore this is supposed to be, the center of this is 35 because 70 divided by 2 is 35 plus 70, that is 105. Okay, 105, and therefore the value of D is actually this one. Okay, the value of D is 600 minus 105. So that is 500. So 495, di ba? So 495. Okay? 495. Okay? And we have a given FC prime, which is 24 and FY is 420. Okay, those are the given. So that's all. So we need to proceed with the solution. So we are actually having this as this is now part of the solution, because we are imagining things that we need in our computation. That is, specifically, we need the value of D. We need the value of D. Okay? And also, we need the value of A. So, let us, therefore, make an estimated area for the remaining concrete. So, that is our A. Okay, that is supposed to be our value of A. So this is A, this is D minus A. And at the center, okay, this is A over 2, therefore this is D minus A over 2. And now we can actually draw the couple. We have tensile force and that is our couple. This is our center that represents C. Okay, so that's all. That is our model. This is our model. Okay, so I can slide it to the right, to the left, so that you can see it. Okay, like that. Okay, so we can see it. So C and T, they are couple. So multiply by the moment arm, so we have nominal moment. So let us proceed to find out the value of T. So for value of T, we need the value of AS. So 3, or rather 6, okay, 6 number 25. What is the diameter of number 25? 25.4. And what is the area for this area of one piece? This is, again, the area is 510. Okay, the area is 510. Just like on the previous, similar to the previous example. But now, the total area of steel is times 6. So 6 times 510, that is, so let's use our calculator again. So 6 times 510, so that is 3060. This is 3060. Okay, so therefore we can now proceed with computing the value of tensile force. So 3060 multiplied by Fy, which is given to be 420. Therefore, we have 420. So we have the value 1,285,000. 1,285,200. Okay. What about the value of C? Compressive force. Compressive force, that is 0.85 FC prime multiplied by AB. Therefore, we have 0.85 FC prime is given to be 24. B is 350. A. So therefore, we can solve for A. So this one divided by this one. So 1,285,200 divided by 0.85 divided by 24 divided by 350. And the answer would be, well, let us compute. So divide by 0.85 divide by 24 divide by 350. The answer would be 180. The answer is 180 mm. And therefore, we can directly move on to solve the nominal moment. So nominal moment, T times T minus A over 2, or 1,285,200. D is, we already find out the value of D, which is 495 minus 180 over 2. So we have the following. So I will slide it a little bit. So slide it a little bit for the camera. Okay. Therefore, using our calculator, 1,285,200 multiplied by 495 minus 90, because 180 divided 2 is 90, so therefore we have 520,506,000. Okay, so if we use the three significant figures, we can have 521 kilonewton meter. So this is our final answer. Okay. Okay. Take note. We use the theory of centroid, center of mass.